Hi, everybody. So in this video, we're going to actually use some of the work that we did in problem set 3.1 and think about profits. So I'm trying to find my sheets here. I probably should have done that beforehand. It says for our first question, return to PS 3.1 and complete the section from MCL to profit. So let's take a look here and try to apply some of our learning that we've gotten about revenue and profit. So first, it says MCL, marginal cost of labor. Now, this is just the change in total cost divided by the change in quantity of labor. It's a fancy way of saying how much does each worker cost, right? But another way to think about it is thinking about the marginal cost of each worker. So it's just like the wage that you pay them, and so that's $15, right? So there's not one for the first worker, but then there's 15, 15, 15, 15, 15, all the way down. Now, this is the marginal cost of a worker. It's not actually the marginal cost of a grebe, which is an important distinction here, actually. The marginal cost of a grebe is the additional cost generated from an additional unit of, or the additional cost generated from an additional unit of output. Now, we know that the only reason that there's an additional cost is because you're hiring workers, right? But the real distinction here is that this one is like per grebe, the marginal cost of a grebe, and this is like the marginal cost of a worker. So in order to do this one correctly, we're going to need a little quick calculator. So I've got my little handy calculator here, and hopefully nobody texts me anything wildly inappropriate during this. So the very first one, right, we're not going to have a unit, but what's the change in total cost? Well, it's going to be 15, right? But it's divided by the change in total product. So for this, right, we're going to be dividing by the change here, which is just the marginal product of labor. So we'd say 15 divided by 5. Well, we should just be able to know that one. That's 3. And then, 15 divided by 7. I'm actually going to move that over just a little bit so it's not in my way. 15 divided by 7 is 2.14. And 15 divided by 6 is 2.5. And these are all in dollars. I'm just kind of rounding like that. Divided by 4 is 3.75. Divide by 2, 750. Divide by 1, well, we don't need to do that. That's 15. And if you're wondering where are these numbers coming from? I'm dividing by this number because this is the change in total output, right? So this is the marginal cost of every single grebe that we're making. Now, for this last one, this is a little weird. It's actually a negative product, so it's not going to be like an additional cost per grebe because there isn't a new grebe being made. So we're actually just going to put little dash marks here and say those are like infinitely expensive because every time we added, we actually lost a product each time. So it's like a really bad thing. You would never produce at those levels anyways, right? We would never hire the 7th and 8th worker because we're losing units. Okay, now we're going to look at total revenue. Now, price times quantity, this is pretty straightforward. The price of a grebe we already established is $3. And so the quantity of grebes is just given over here in this column, the total quantity. And so we'd say 0 times 3, well, that's 0. And then 5 times 3 is 15. 12 times 3 is 36. 18, I'm just going to do this. 18 times 3 is 54. And 3 times 22 is 66. 3 times 24 is 72. 3 times 25, that's 75. And then we've got 72 again and 66. Now we're going to do the marginal revenues. Now this is the change in total revenue divided by the change in total product. Now for each of these, it's going to be a little weird, but we're going to notice something that's going to start to emerge actually. So we're changing by the total product. Now we can't just divide by 1 each time because this is the quantity of workers. We're actually going to divide by the change in the product, which is 5, 7, 6, 4, 2, 1, -1, and 2. So let's see what happens when we do that. Change in total revenue. Well, the change from here to here is 15, right? Going from 0 to 15. So 15 divided by 5, 3. Now that one's, there's no unit there. 3. Okay. Now we've got 36 minus 15. Okay, 36 minus 15, because it's the change in total revenue, divided by the change in total product, which is over here, 7, 3. Weird. Now let's see here. 54 minus 36 divided by, and how many did we make that time? We made it 6, 3. And this one is going to be 66 minus 54, that's the change in total revenue, divided by 4, 3. We start to notice a pattern here, y'all. 72 minus 66, 72 minus 66 divided by this one, 2, 3. I bet the next one's going to be 3. 75 minus 72, you should be able to do that in your head, but 75 minus 72 is 3, divided by 1 is 3. Now, these don't exist because we have a negative product, so those don't count, right? Now, a couple of things that should emerge here. Number one, we should recall Mr. DARP. Oh, sorry, Mr. DARP, just like that, right? And one of the things that Mr., the MR, and the P are equal in Mr. DARP. So price is marginal revenue. We could have actually just said, hey, we know marginal revenue is price, so it's $3 the whole way down. But you can really work it out and actually see that difference as well, just like we did here. Now we know that profit is maximized where MR is equal to MC. So let's take a look. Oh, cut that off there. MR equals MC. Where would, right, the marginal cost, where is it going to equal? Now, I know that you're immediately going to say, Mr. Glasser, it says 3 right here, and that's 3, and you didn't stop there. Okay. Well, the thing is about marginal cost is that it's going to come down and then go back up again. So we're going to want to keep going past that first one, right? Past the first one until we get to that bottoming out point. Now, here we bottom out at 2.5, and then, we bottom out at 2.15, and it starts to come back up again with 2.5, and then it gets to 3.75. So we definitely aren't going to produce this one because this worker, this fourth worker, 3.75, the cost is bigger than the revenue, right? So this one we won't produce. And this one, 7.5, well, that's way bigger than 3, so we won't produce there. 15 is way bigger than 3, and we know we won't hire these because they were giving us negative anyways. So I'm going to bet that this one right here is our profit maximizing point because it's the one right before, it's the closest we can get to where marginal revenue equals marginal cost, where we aren't going over. Now we'll see if I'm right? We'll see. So total revenue minus total cost. So total revenue is 0 minus total cost is negative 10. That's bad. Now we've got total revenue 15 minus total cost is 25, so it's negative 10. Oh, that's bad. That's not good either. Now we've got 36 minus 40, negative 4. Well, we're still losing money, but less each time. And now 54 minus 55, negative 1. Now I said profit maximizing, but you notice we don't even have profit here. But let's see if it gets any better. 66 minus 70, negative 4. 72 minus 85, that's negative 13. 75 minus 100 is negative 25. This company is not doing well. This is 28 and 15 is 38, 43. 43, oh my goodness. And then we've got negative 64. So important to observe here, this company at no point earns any money. This actually, if you're wondering, where does this data come from? This actually comes from a class simulation that we did last year in class. And this was the real data from this group. So they never actually made any money when they were doing this in class. But the least amount of money that they lost was here, right? And it was actually like magic. This is the last point, the last worker before the marginal cost gets bigger than the marginal revenue. And so this rule, MR equals MC being profit maximizing, still holds true even when you're losing money, no matter what, right? Would you rather lose $1 or $10? Well, you should operate at a loss for a little while and see if it gets better, but you're going to lose $1, and that's the best of all of the worst outcomes. All right, now we're going to go back to the practice problems. What quantity of output maximized profit? Well, it's maybe better to say minimize the loss. And the quantity of output was 3 workers, or actually 3, and the quantity of output was 18 in that case, right? And then it says, what were MR and MC at that quantity? Well, MR was equal to 3, MC was 2.5. Was the firm profitable, or should it have considered temporarily? Well, maybe it should have considered shutting down. And we actually would know whether it should shut down or not. And here's how. What should it have done? Should it have shut down and not hired any workers? Well, it's still going to have to pay that $10 for the machinery. So in that circumstance, it's going to lose $10. But if they operate, they're going to hire 3 workers, they're only going to lose $1. And this is actually an important thing. It happens in the real world. You may not notice it, but it happens all the time. Restaurants pretty commonly are open from like 2 o'clock to 5 o'clock, even though they don't usually generate very much money then. They might even be losing money from 2 o'clock to 5 o'clock. But they lose less money by operating than they lose by shutting the doors, because there's still going to be a few customers who come in at 3 o'clock, 4 o'clock, that kind of thing. So that's actually why businesses will sometimes still be open even when business is slow, because they lose more money if they close the doors. Okay, now this next part is actually going to be part 2 of revenue practice problem sets. So go ahead and watch this Jacob Clifford video. It's in the playlist, and then we're going to return and do a second revenue practice. I'll see you next time.